And hello. Today we're going to talk about making a fraction from a repeating decimal. It's pretty straightforward. They all work the same way as long as it's a repeating decimal. So let's get to it. I'll start with an easy specific example of just 0.3 repeating. So it's 0.33333333, which is 0.3 repeating. Okay, so we want to make a fraction out of this. Now, most people probably know 0.3 repeating is the same as 1/3. Well, we might not know that. So let's set this number equal to x. So I'll set the repeating decimal equal to x. X equals this 0.333333, repeating. Okay, now we're going to multiply x by 10 to the first power because there's one repeating digit. So again, here, how many digits have a bar over them? Just one. So that's why one repeating digit will multiply by 10 to the first. So 10 times x is 3.333333, or 3.3 repeating. Okay? And you might ask why I would want to do this. You'll see. Okay? We'll subtract. We know 10x is 3.3 repeating, and we know x is just 0.3 repeating. If we subtract, we'll get 9x equals 3.000000. Each of these 3's, 3 minus 3, 3 minus 3, 3 minus 3, they all cancel out. I get zeros for all of them. And you can even see here, 0.3 repeating minus 0.3 repeating is going to cancel out. You'll just get 3. So 9x equals 3. Well, if 9x equals 3, divide both sides by 9. X equals 3 over 9, or 1 over 3, 1/3. So there you have it. X equals 0.3 repeating, or 1/3. Again, you probably already knew that. But now you have a strategy for attacking ones you might not know. You might find this one rather shocking or surprising. 0.9 repeating. Basically as close as you can get to 1, right? Without equaling 1? Or does it equal 1? Okay. Well, so it's 0.9999999 on forever. So we'll set this equal to x. Do the exact same thing as we did before. Only one repeating digit, only the 9 is repeating. So again, we'll multiply by 10 to the first. 10x equals 9.9 repeating. We'll subtract. 9x equals 9. And you can probably already see where this one's going. If 9x equals 9, then x equals 9 divided by 9. X is 1. So 0.9 repeating does in fact equal 1. It's not infinitely close to 1. It's not just under 1. 0.9 repeating does in fact equal 1. So I know there are probably some non-believers still out there, but in fact this is true. Here's one you may not know. Whoops. 0.428571, 428571. It's a kind of famous one, but you might not recognize it. So this 428571 continues to repeat. So we'll set that equal to x. And now there are 6 repeating digits, 4, 2, 8, 5, 7, and 1. So we'll multiply x by 10 to the 6th power, or 1 million. So if we multiply by 1,000,000, we get this. And you can sort of see why you might multiply by 10 to the power of however many digits are repeating, so that this repeating starts back from the beginning. Okay. So if we subtract now, we have 1,000,000x equals 428,571.428571 repeating. Subtracting x, which is just 0.428,571 repeating, We subtract those, we get 999,999x equals 428,571. All right, and then you divide. So if 999,000x equals 428,571, divide both sides by 999,999, and you get x is 428,571 over 999,999. An excellent fraction, but I'd rather reduce it if possible. So you just divide by 142,857, of course. And again, okay, you might not realize that that's the number you have to divide top and bottom by, but you could just start off small. You can see 9 probably goes into both of those, and then maybe another 9. Just try some numbers. You eventually get it down to 3/7. So in lowest terms, 0.428571 repeating equals 3/7 exactly. So this will work for any repeating decimal as long as the same thing is repeating over and over and over and over. Whereas something like pi, you don't have the same thing repeating over and over, and therefore you can't write it as a fraction. Same thing with square root of 2. There's never a constant repeating pattern, so you can't write something like that as a fraction, and that's why we call it irrational. It's not able to be rationalized as a fraction. All right, thanks for watching, and I'll see you later.